The title is Method for Collaborative Recommendation in Document Retrieval Systems. And here's my outline. After a short introduction, I would like to present the overall idea of the method of collaborative recommendation using usage-based classifier, and then some experimental results and summary of future works. Collaborative recommendation is usually understood as in these two ways. So first one is given a new item to be recommended, predict the rating of the user that user can give, or given a new user, find the best items and there is recommendation ratings showing the results. So we can reorder some list of documents or products. The other one problem with recommendation is always cold start, because when we don't have enough information about the user or about an item, so documents, products, and so on, we can't say anything about how it will be rated. Normally, so in standard classification, because collaborative recommendation is connected with using some knowledge about other products, so normally there is a training set, so we just train some models, tune some parameters, and then test this approach, these parameters in the testing set. In our approach, we would like to propose some another way. So the first step is made using demographic data and usage data, and the details I will explain in a minute. The overall idea of our recommendation system, our approach don't assume that we recommend some documents or other products, but we recommend the profile, because this research are connected with document retrieval. So I would like to say about documents. So first of all, we have set of users, and the user profiles contains demographic data, so some age, gender, and so on, and usage data transformed to the profiles. This profile is really a vector with terms, with weighted terms. If the weight is higher, then the interest in this term is higher. First of all, we would like to cluster these users, but using these profiles, and then our novel, I think, method is to develop classifier for obtained partition, because here we obtain some partition, and in this step we would like to choose some subset of the demographic data to fit in the best way. What is the best way is another question, but to fit this partition, but using not the profiles, because for the new user we don't have the profile, but we can ask him only for this demographic data. So we would like to minimize this subset of attributes that the new user need to give us, and using this subset, we can classify this new user to the right group. Right means the group of probably the most similar users. So when a new user is coming, he is classified to the right group, and then we can recommend him a non-empty profile. So this, I hope, we hope that the recommendation, the recommendation of the products, of the documents, in the next step really will be better than if the profile will be empty. But our research are connected only with recommendation of this profile, because if we have profile, the recommendation using profile is, I think, known methods. Many methods are known, are prepared, so we can use one of them, for example. The demographic attributes that can be collected in the beginning when new user is coming to the system and is registering in the system. We have considered gender, age, size of living town, it's really town or village, for example, or country, education, employment, and favorite browser and favorite color. Why it's because in information retrieval, maybe the browser is connected with information retrieval, but this favorite color is really taken from some psychological, in the border from psychological research. Maybe if someone prefers red than green, he would like also prefer some other domain of information, of documents or something like that. It's one of the of another document, another attribute not connected really with the, for example, age and so on. So really demographic data, but all of them are named here as demographic data. The first step is clustering. So after the clustering, we have some partition. So we have disjoint and non-empty classes of which are a subset of the whole set of users. And the most important part is distance between partitions, because we need to compare the partition obtained in one classification process and in another one. We use some method. Here is really in a matrix. If in the matrix is 1 if two users are in the same group, or 0 if they are the other way. 1 if they are in this different class, and 0 if they are in the same class. And we just count the difference. It's normalizing factors. We can't use algorithm that would. We can use only approximate algorithm because of computational. So the first one, we have partition to determine this usage-based classifier. We have in the input we have partition of the users and this distance measure as I presented before, and in the output we would like to have the minimal set of this subset of these attributes that are the most important for our classification. So the idea of algorithm is, I think, simple. We choose the first attribute as such that this distance is minimal, just for only this one attribute. Then we add the next one, the next attribute, and also choose this one, that's this pair of attributes, minimize this distance, and so on. And we stop when the distance is not higher in the next step. So adding the next attribute will not minimize our, the distance will be not smaller than without this attribute. And some results from this part of experiments, and using this attributes, we can see that the gender and size of town, so village or country, town or country, and probably age, these two are the most popular, the most fitting, the best one for this classification. The age, browser, and education are the second part that are almost the same average frequency. We have done the simulation for 200 and 2000 simulation, and these are average values. And for most popular pairs are gender and employment, gender and age, or gender and education. So this gender is in all these pairs. And also here is gender and town. So town size of the living town is always in each triple, and here is browser age education, and so these triples are comparing with this one. So we have gender and town, and one of these more smaller frequent, less frequent, sorry, parameters, attributes. The second part of this algorithm is determining centroid profile, and here is I think it's also just quite simple algorithm, because if we have profile connect with terms with weights, we calculate just average weights for each profile, for each term. So here is such simple, the simpler one, the simplest one, I think, because it's a natural way to calculate the centroid of the group, having such objects in this group. When we considered in another work, when we consider hierarchical problem, there were some more problems, and this algorithm was more complicated. But here is only the simplest one. And the recommendation procedure I can present in the following way. We have a set of users and this classifier from the previous step. We ask a new user for attributes only for this subset of this. So instead of asking him for all 7 or 10 parameters, we just can ask about gender, town, and, for example, browser, and classify him to the appropriate group, and recommend a centroid profile calculated in the way I have presented. And in each step, because I would like to check if this is if this idea is right, I can say. So in the first step we have 10 users, then we classify them, cluster them, and and we calculate the distance between partition, and then we add 10 new users, and we do it many times. And our aim is to show that if we have more users, if we have some more information, more knowledge, these distances between partitions obtained in the clustering procedure and using only this demographic data will be the distance will be smaller, and the first results show that in the beginning here we need to collect some information. So we need to have some users, some group of users, not 10 but maybe 200, and after that we can see that this the proposed method seems to be good, but here is only adding 10 users in each step. So I think it can be good, but it needs to be checked. So in a future work, maybe I'll start with this part. First of all, I need to check it for a bigger data set, for some another maybe set of the user, and some methods, developing some method for hierarchical profiles, maybe ontological also. But in this research, in this paper, I presented a method for determining minimal set of attributes, method for profile recommendation, and I think this methodology of experimental evaluation, because I haven't found it in some literature, in other papers. But I have, maybe I can ask if someone knows how to evaluate in another way such approach, our algorithm, I would be happy to to see to know how to do it in a better way. So thank you for your attention.
Okay, thank you very much. Now I open for Q&A.
Okay.
I'd like to ask, because you retrieve the documents according to the user profiles.
Yes.
And the question is, what repository of the text documents you use?
Okay. All these experiments are made, are performed on the simulated, in a simulated
Also repository, documents repository.
also document, because I assume that each document can have from 3 till 5 terms, yes, with weights that describe it. Because using some real database needs to more time for performing these experiments connected with searching.
So if you use a user profile, which is also simulated,
Yes, of course.
how you put the name of the attributes to the profile?
Okay,
Because it's also artificially.
yes, it's artificial. The most important reason that why I use simulated data is.
Yeah, it's okay. I understand.
Okay.
Because you don't have such a.
I don't
data.
have. This is the first one, and the second one is that if I generate some data using, I can say different distribution. I have information about some parameters of this distribution. If I ask 10 people from this room, for example, for some data and for some profile, it cannot be representative in enough way. It can be not enough representative data. And going to your question, I use some information, statistical information from people or population of Poland. So for 51 and something percent of population are women, and the rest are men. We have more women. Another part, I use joint distribution connected with living size of living town. So there is. I have.
Okay, that's right. So you took the.
Yes.
The
There's some statistical distribution, yes.
From the real data.
Yes, I have distribution, so I hope that it can be reflect my result. And using simulated data, I can say something about statistical results at the end. But using only as I said, using only some information from the asking some people. I need to collect many people that would have interact with my system and so on, so on. So I'm not sure it is possible to do.
It's a nice idea to simulate.
Because sometimes, for sometimes,
For some
about the recommendation system, sometimes the real data will be easier than the selection data. Because usually in the real data, you have, actually the real data is composed of some hidden features about the user behavior and the document behavior. So sometimes I suggest that maybe you can to define clearly about your scenarios, because the scenario definitions will to define the scope we want to work on. For example, about a document is a very, very wide concept. Okay, because if you want to recommend the music or the movie, the features is quite different for the targets. So when you want to do the recommendations, the first thing maybe you choose the good feature, and if you choose the features are good enough, it's not stable features. Actually, it's very, very difficult to have a good result. So maybe think about how to define your scenario first, what kind of document you are focused on. Maybe, for example, in our previous study, maybe define on the sport news, because sport news is have clear features about it, because the name, about the terminology is more clearly than the others. And for example, the fashion news is also a good target to study on, because maybe from the feature you chose, I cannot see the features can fit to what kind of target document. It's too general. Yes, very, very general.
For a moment, I was cooperate with a library in our university, so the specification of these attributes would be another. So the maybe age and gender and living town, but for example, specialization or faculty of his study and so on. So these attributes are only assumed because I have information from statistical data, from some statistics, real statistics from our country.
Yes, so that's why I suggest to define your scenario. Yeah,
Okay.
because some document maybe have is a suitable. You use, for example, use gender for as a feature, right? Some document maybe is sensitive to the gender, but some document not.
Sure, thank you for
Thank you
this.
very much. Now can we give a big applause to the presenter? Now I would like